It's okay.
It's going to be amazing.
Yes.
It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool. It's going to be amazing. It's going to be amazing.
That's probably enough drinks for tonight.
That's so cool.
It's okay. It's okay.
That's so cool.
That's probably enough drinks for tonight.
That's so cool.
It's okay.
It's going to be amazing.
It's okay.
That's so cool.
That's probably enough drinks for tonight.
Oh, hello everyone. Welcome to another Percona MeetUp. This week is our MongoDB MeetUp week. So Glad to have everyone on with us. Here, joined with Andrew and Kim. Hello. So, welcome everyone who is virtual. Welcome to those who are watching us recorded. Thank you for coming and following along. Oh, and there's Kim. Welcome, Kim. Here we are with another fun and exciting week. So, before we begin the MongoDB fun, I was just at a conference. This is actually the second conference in the last 3 weeks that I've been to. Kim, you were at Open Source Summit with me, and so we're starting to get back to in-person conferences, which is always fun. So I don't know about you, but I like to get in person and talk with people. It's always fun and exciting, it's definitely one of those things that I'm trying to figure out which is the best angle for the three of us. I think this one is, yes, much better.
Yeah, Matt. Matt, you're right. It was nice to get back out there. It was a little kind of interesting because it's the first one out in 2+ years. So, but it was good to get out there to see people, and I think this will kind of get things started up back again, right? Because it's definitely a difference, especially if you're talking or presenting to people and on a topic, because you can see the reactions, you can gauge what they're most interested in, and kind of go down that path and that alley. So.
Right. Yeah, it's hard when you're virtual, especially when you're not seeing the participants, right? So, we might have 100 people watching this, and we might say something, and they go, and you won't see that reaction. Or they might say oh, tell me more, but we don't see it.
The funny thing, good if you have us 3 participants, but when you alone and you just staring in your monitor and in your camera and you just talking, it's it felt a bit off,
Well, yeah, because you're staring at yourself and you're talking to yourself. So
yeah.
I don't know about you, but sometimes I find myself going oh, is there something in my hair?
Right?
Or my glasses,
Exactly.
Horns, right? Yeah, exactly. Yeah. Or am I looking at the correct camera, right, as opposed to the laptop camera? Yeah.
Yes, right. So you've got all these different ones. It's a challenge. But I was at All Things Open this week. Oh, look, someone's eating borscht and listening to you. Couldn't do that at a conference. That is true. That is true. You couldn't eat borscht and check us out at the conference. So, lovely that you're able to do that. Welcome all across the world. And that's one of the nice things about virtual and hybrid events is you can reach out and talk with folks no matter where they are, anywhere in the world, which is very cool. But I was at All Things Open this week. So if you're not familiar with All Things Open, it is a 100% open source conference, very focused on the community here in Raleigh, but also worldwide. And it's interesting. So based on the 2 conferences we've gone to, looks like about 20 to 25% of what a normal conference would be, that's who's attending in person. So it's still not back to normal 100%, but it is fun and exciting and engaging to do that. But as I was there, I was able to talk to quite a few people. And of course, everybody's there loves open source, but this is a very developer-focused conference. And there were a ton of students, a lot of people from colleges and people going through learning how to be engineers, learning how to, design applications. So a lot of them are ooh, databases, yuck. But almost all of the students were oh, Mongo. We know Mongo. We use Mongo. Yeah. And so it's interesting to see that there's this, kind of reaction to ooh, databases, but then Mongo, they're oh yeah, Mongo. So you talk about that kind of inflection or that face, right? It's the ooh, databases, Mongo. And there is that reaction. Why do you think that is? I have my thoughts on why Mongo's so popular, in that kind of student developer crowd. But maybe Andrew, what have you seen from the Mongo community that makes it so attractive to those developers?
I don't know, man. For me, it's surprising as well because, for me, it's databases. What could be more excited than databases? I'll probably maybe compilers. But on the other hand, if like what could be more excited than distributed databases? Yes. And Mongo what offers this, but again, I don't think that this is the case. I think it's probably the like more younger generation, the students, they are feeling like that's this is like some old technologies that like the Postgres made in late 80s and early 90s. The same with like MySQL and mid 90s, and so probably this is like the technology that started before these people were born, and and like this new kind of fresh technology maybe feeling more appealing and more like refreshing and more like closer to that generation on one hand. On the other hand, it's like big deal is like the easier entrance to this technology. You don't have to know all this like SQL, and you don't have to understand like this whole new world and all this new language. And if you like dug deeper, like all this ACID, what is transactions, what this level of is isolation and stuff like that, you just installing and using it, and we spread of this like APIs everywhere, JSON, and again, it's like very appealing and things that people could understand and easily like. So
yeah, it's definitely easier for people to get started with. But where are my manners? Andrew, I did not introduce you properly. Can you introduce yourself to those who are watching, who might not be familiar with you? Maybe tell us a little bit about yourself, where you're from, just so people get a sense for your background.
Yeah, sure. My name is Andrew. I'm a principal software engineer here at Percona. I came, like my first project that I used to work in Percona was databases in cloud, in Kubernetes. Yes, and since then I switched to PBM, Percona Backup for MongoDB, and I found that like again this project like more interesting and appealing to me. So since then I've been working on the PBM.
And PBM is
originally
Percona Backup for MongoDB.
For MongoDB, yes. So basically, this is like distributed backup for Mongo, fully open source as always. Yes, and quite neat. I was born in Ukraine, but now I live in Cyprus.
Okay, great. And Kim, maybe introduce yourself while we're at these introductions.
Yeah, it's Kimberly Wilkins. I'm the MongoDB Tech Lead here at Percona. And so I've been working with MongoDB since, I don't know, late 2013, early 2014. Before that, I did a lot of Oracle. So for me, it's kind of the different things, right? For me, the developers won in a way, right? Because before in Oracle and the relational database, you have schemas and the developers have to fit within these schemas. But then you get to MongoDB and it's quote unquote schemaless. But if you do that, of course, you're making a mistake from the beginning. But you do put structured, semi-structured, and unstructured data, and you can figure out what to do with it later. And so that's one of the things that made it significantly easier for developers to just, hey, let's throw this in Mongo. We can put whatever information we really want in there, and we can figure out how we're going to use it later, or we can use it however we want. And so I think there are a lot more developers than there are DBAs. And so that's kind of like one of the historical quote unquote battles between that. But I think that Mongo did a really good job early on with the developer community and getting them on board and live, and some of that's kind of changed over the time, but they're working back towards that. So, and I think that that's super important. Like, for example, our comment here, I found out about MongoDB when I decided to become a developer and started to learn front-end development and mobile app development. Those are some of the things like mobile apps, product catalogs, all these different types of use cases, chat messages, et cetera, are perfect for Mongo with the semi-structured and the unstructured data, right? So.
Right. Yeah, and I think that's where it's become really popular, especially in colleges, universities, because there is an easier barrier to entry. It makes a lot of sense from a front-end perspective to keep things very close to what the app itself is doing, so that based on the BSON format or the JSON format makes it a very easy transition from one to the next. Now, Andrew, you mentioned, you're specifically working on PBM. You used to work on some of the Kubernetes side of things, which,
right.
that means you've been in all of the new, the new exciting world of
and
cloud
trendy stuff. Yes.
Yeah.
Yes.
So you're at the cusp of the cloud native movement there. And, one of the things that is super interesting about Mongo, and this is one of the things that, when you think about a classic database setup, you don't generally think about. It's now that we get to this cloud native environment where it becomes super relevant. And what that is we've got, copies and clusters of data that are spread across multiple nodes all over the world, potentially, or all across different servers, which means that backups become kind of a tricky thing. Like, you think of a backup, on your PC, on your Mac, wherever, and it's like, oh, I'm going to run, the backup, tool, and it's just going to back it up. It's going to take care of it. Everything's good. But now you might have 5-10 different servers, all with a piece of the data. And when you run a backup, the backup could be at a different point in time on every single node. Right.
Yes. Yeah. You're right, and this is like one of the reasons why I switched to this project, because this is that it has some amount of like challenges and complexity that related to that matter. That you mentioned totally right. That one thing that you have like one standalone like database and you have to do backup, it's like pretty straightforward. You just do backup and that's it. With Mongo, when you have even if you don't have like sharded cluster, if you have just a replica set, still you have, let's say, at least 3 nodes, and then you have to decide which of these nodes going to be taken backup from. And again, these nodes could, as you mentioned, distributed all across the globe. It could be like in different regions, even on different continents. And if we add to this like the new layer of complexity is like the sharded cluster. That's when you have like these replica sets, but the set of these replica sets, if you will, and they are again could be spread across the world, or part of this could be spread across the world, doesn't matter. And then you have to decide not only which node gonna take backup on each replica set, but you have to be sure that every node on every shard, not that every node, but at least that one node on every shard gonna make the backup. So this backup gonna be consistent. And then you start thinking, okay, how can we be sure that this backup gonna be consistent across all of these shards? So yeah, it's really challenging.
Yeah, and I think that's one of the things we often take for granted, because when you run a backup command, it's generally just a backup command. It could, in some databases, it's easy backup, right? Like you just type backup and then like the name of the database, and it just happens.
Yeah, right. And then that's super important too, because if you think of like historically the backups, right? From the logical point of view, you have logical and then you have physical backups, right? And historically, we primarily did logical backups, right? We did them from within the database. But as these database sets have grown, as the data sizes have grown over time, then that's much less practical, right? Because it takes a long time to take that backup as the size grows. And then it also takes a long time if you need to do the point-in-time recovery. And that's why the physical backups have become more important. And like Andrew was just talking about a minute ago, that kind of leads us to the point-in-time recovery options that we're talking about, right? But your logical backups for Mongo specifically, because that's what we're talking about, that's going to be the ones from within the database. It's going to capture everything within the database, including like the config database and the information there. And everything from within the database. And historically, that's going to be your Mongo dump, your Mongo restore commands, right? But you can really, really, really take a long time to do those with terabytes and terabytes and terabytes of data. And not only that, the restore is going to take, but it's also going to have a negative impact on your performance, right? So as we scale, we need to be able to address that. And that's where the physical type database is.
Oh, Kim just went muted.
Yeah.
Like we just lost all your sound.
Whoopsie daisy. All right, which part did we get? So that's where I think my hand hit.
It's terabytes and terabytes,
Yeah.
and then
Okay, so I think my hand hit the button over here. So sorry about that, guys. So terabytes and terabytes of data, right? As the data sizes have grown, it's become more and more important that we're able to do the physical sizes, because if you're doing the logical backups and we're this large, terabytes and terabytes of data, it takes a while to back that up, but it also takes a while to restore that. And then during this time, you're doing multiple writes, so you could possibly impact your performance. So going back to the replica sets that Andrew was talking about a minute ago, you can do it on other members of the replica set, not on your primary. You can do it on one of your secondaries, as long as you're not doing too many secondary reads. You can add a hidden node there to do the additional setups. And then to where Andrew was going a minute ago, then we're talking about the physical backups. So yeah.
But wait, I know that there's going to be somebody who watches this video, and I'm going to play the devil's advocate. I wish I actually need like my soundboard setup, which I don't have with this, so I can like play like some like eerie devil's advocate music, or maybe horns can pop out of my head or something. But playing the devil's advocate here, with all of the redundancy, why do I even need to back up? Isn't MongoDB supposed to be resilient?
MongoDB is inherently resilient because of the election, because of the replica sets, right, itself. But especially if you're talking about multi-zone, multi-data center, multi-region backups, you never know what's going to happen with the latency, right? And so you do need to be prepared. You do need to. And so one good thing about the logical backups is that you can do a backup and restore just to a collection level or just to a database level instead of the complete instance level. So if you wanted to test something just on one collection for development purposes, then that's a great thing to do, right? As opposed to having to do a complete restore of everything. But you always need backups. You always need backups, because what happens if you lose an entire data center? Or what happens if you lose 2 data centers? Or what happens if you have your replica set or you have your shards and you lose your primary and it does an election? And if God forbid you had an arbiter, if you have a primary, a secondary, and an arbiter, and that's all you have and you're running that in production, okay? And then you lose your primary, and then you only have one secondary, and then it's catching up. And the arbiter is not a data-bearing node. So everything's important about the architecture. But if you have a backup, you are taking precautions. And you really just have to have that in any kind of production environment.
Andrew, what were you going to say?
We not even haven't talked about human factor, because you can have as much resilient database as you can have in this world, like imagine with like bulletproof data center, but it doesn't protect you like from the human factor. Oh, we are human, we do mistakes, and if somebody has access to your database, like I don't know, developer, DBA, anybody, you never know. Potentially, somebody could like just hit like delete everything.
Oh, you mean somebody might delete some data?
Yeah, sure. Why not?
Or with 5.0, 5.0, 5.0.1, 5.0.2, and backported to 4.2, 4.3, all the way to 4.8, 4.9, there are bugs that were introduced by backporting these things that are data and potentially data impacting, that could cause corruption and or missing documents. So, okay, you decide to do an upgrade because upgrade to the latest and greatest. That's what you need to do. And even if you're still doing only on 4 whatever, but if you upgrade to that and you corrupted data and you've already migrated and it's already the changes have already gone to your secondaries, then you're in trouble, and you have to do a validate command that across all collections and all of your databases, and that's a very impactful command. So yeah, backups are a very good thing. Before any upgrade, obviously you want to take an extremely solid backup.
Well, and this is an interesting point. Getting back to Andrew's point here a second about the human factor, right? If for those who aren't necessarily DBAs or have that kind of sysadmin background, think about as you replicate data and you have these copies of data sets on different servers. If you change some of your data on server A, that change moves to server B and server C. which means that, like, so if you make a change to, I'll just use something very, easy. Let's say you're tracking bank accounts and you say, let's zero out my bank account on server A. That gets zeroed out on server B and server C eventually. And if you didn't mean to zero that out, you don't have the redundancy to go to the other servers because they all have zero now. And that's where backup matters. Now, I'll give you an example that is a real world example that I've used before in talks. Where, and this is not Mongo specific, but this happens in every database, right? Regardless of the redundancy and things you put in. Yeah. There was a company that we worked with way back in the day. They gave us a call. They were a internet unicorn. So if you're not familiar with an internet unicorn is, it means that they're worth $1 billion, right? So $1 billion plus. So very, very large company, a darling of the tech space. And this was years ago. And they actually did that they had all this redundancy built in. They had replicas and primaries, and they had failover and clusters and everything else going. And with that setup, they moved data centers. So from data center A to B, migrated because they wanted to switch providers. And on the second data center, they forgot to turn backups on. So they had all the redundancy. Everything was copied over. And if one of the nodes failed, everything was perfectly fine. But one of their developers released a new version of the code. And accidentally in that new version of the code, it was a migration process to a Ruby on Rails. It recreated the tables. Yeah. And so it dropped all of the objects, recreated all of the objects empty. Yeah. Yes. And there is no recovery from a failover perspective. Yeah. Right. And I think that is something that you have to be mindful of. And that particular company, we used to do a lot of data forensic recovery, which is even if you delete stuff, you can still get it back from the Linux file system. It's just not a fun process. So we spent about 4 days doing forensic data recovery on, Linux to pull back some of their data. But they had a 4-day outage on their website. And after that, they were out of business in 6 months. Yeah. And with today's always on, online, immediate access, immediate results, you can't have that. You cannot have that as a company, right? I mean, it's not the same times. It's not green screen days, although we do have a green screen here, but it's not the same as the mainframes and the green screens where you can take that much time, right? And this goes back to the point of there is still a place for the logical backups, right? The per database where you can restore the collection. So we had someone talk here about backups can also be a form of compliance. Yes, right? You must be able to recover. You must be able to have your backups in place so that you can recover. And you have to the majority of the time, you need a median time to be able to recover, right? So. Yeah, and the other thing, you probably won't, in some cases, have ability, like to travel in time, backwards in time. I mean, to have, because let's say your data changes, your account changes, or some other data changes. Okay, maybe you have logs for all of that, but in general, this ability to, let's say, to be able to travel in time and to see what the state was like. It's not that I think widely and spreadly used, but still for some type of businesses, for some companies, again, it could be, I suppose, even some obligations that applied by. Yeah, and I mean that point in time recovery, Andrew, is very important. And part of the thing that's in PBM is that point in time recovery, right? And so how does that work? In general, we just using let me make a bit step back and explain in general how does replication in MongoDB works. Basically, in the replica set, canonical, let's say, replica set, we can imagine it's one primary and two secondaries, and the primary is write read node, and from
like secondaries, the followers, you can only read the data. And basically what's going on that, again, this replica set elects primary. So let's say, imagine if your primary gone because of some network issues or whatever, just the other, like one of the secondaries going to be reelected as a primary. And so basically, whenever you write to the MongoDB replica set, being like replicated to the secondaries, and this is done by the like op log, like operation log. Basically, it's like some kind of like broadcasting protocol when the followers, the like secondaries, just subscribe to the primaries, let's say, events, and basically primary sends all the events that happen in the system, but again, only event that concerns any changes of the state. So basically some writes and updates.
Yeah.
And basically, again, one of the, along with the data, the primary MongoDB would send this like the cluster time. This is some internal, I can try to explain it more if you will, but in general, this is some kind of ensuring this, like say, like ordering in time of the events, that the cluster knows that again, the replica set, Mongo replica set has like let's say like casual consistency. So basically the events that are related to each other are guaranteed to have, like say, some order. So you can see your write, you can read your writes, you can read your reads, that's and so on. So basically this is like so every in the op log, when the primary sending this the data to the secondaries, it also contains this like cluster time. And basically by this, by reading this data and reading this like cluster time, we can recreate the chain of events that happen in cluster.
Yes.
And we can know at what time what event happened. And one of the cool feature of oplog is that independent, I always mispronounce this word. Basically, you reapply this the same event, and it leads to the same result. You can reapply the same event like 100 times. It changed nothing. It's going to be the same. So you just can like reapply it, and data gonna be fine. So basically, like in general, we just reading this oplog, storing this oplog, and like again in special format that we know that which part of the oplog relates to which time and date. And basically what we are doing then, we just applying, let's say, if we want to restore to some point in time, we just apply in the backup, and then we just like replaying all the events that after the backup to the point of time. So
where this becomes important, that the case that I gave earlier with the unicorn who didn't have the backup, and they had basically their tables got wiped, or their collections got wiped because of a migration. This is where you would say the migration happened at 10:05 p.m. We want to go back to 10:04 p.m. and restore that.
Yeah,
because one of the problems with a lot of backups when you do like a full backup is it's at whatever point in time you ran the backup. So if you ran it 24 hours before you had an issue, you lose 24 hours worth of data without that kind of point in time recovery capability.
Right. Yeah. For those people who are more used to like relational databases, for example, Oracle, you can think of it like it's like the SCM, the system change number, right? For the point in times, you apply the redo logs, just like the op log, right? So the equivalent.
Yeah, like write a head log or something like that.
Exactly. Right. And so by having the point in time, the larger backup sets, you want to make sure that you can then apply the op log. And the other thing you want to do, of course, if you're planning and you're scaling and you want to have the shortest possible time to recovery is to make sure that you're taking your backups frequently enough, right? So that if you have a, I don't know, 5, 10 terabyte database, whatever, that you're not going to have to apply 50 million or however many oplog changes to get back to the point in time, right? So that's the other thing. As a business, you need to determine what your absolute maximum amount of time is that you want to be able to take to recover, right? And then you'll take more frequent backups if you have to be able to recover more rapidly.
And this also leads me to another point that I wanted to discuss, that you have to have, even with like point in time recovery, you have to have some decent like frequency of like backups still. Not only, of course, this is 100% true that you don't want to like reapply all the chain of the event, because you can maybe just, you imagine you have some record which is like changed like 100,000 times from 0 to 1, from 0 to 1, from 0 to 1, and you just you have to like make this 100,000 of write operation just to came to this like 1 byte of data, yeah. And but on the other hand, now imagine that you have one backup, let's say that you made like 2 weeks ago, and you have the uplog, and you want to restore to some, like to 1 hour back. You're starting to restore, and it appears that this backup is broken. It doesn't work. And that happens. And then you basically screw up. What are you going to do? Because in order to apply uplog, you have to apply it on top of something. And if you don't have like base backup, it's not going to work. Yeah. So like, again, some people probably may think that, okay, I'm doing backup, I'm fine, I'm protected. Of course, this is like much better than not doing backups at all. But I suggest keeping in mind that you have to test your backups, because again.
So let's do a PSA right now. So hold on. I'm gonna do this PSA right now. Okay, so I'm gonna go. If you're watching, test your backups.
Always test your backups, just like test your code before you put it in production. Like, yes, definitely test your backups.
Yes, test your backups, people.
Yes.
Yes, and this is like, it's so many layers in that, because like, again, from more obvious thing that if your backups doesn't work, you want to know it beforehand, before you like relying on that and build it. Because again, nothing is bulletproof. You could work. Probably something went wrong during the backup. Probably something went wrong with I don't know, the hard drive that this backup was solving, some broken sector and stuff like that. And on the and along with that, if you are like time to time testing your backup, it's just usual and comfort procedure for you, and you more or less familiar with that. And when the time happened, you already, when you have to restore like in production from the backup, it's so stressful situation, and you don't want to add extra layer of stress by dealing with something that
some people do. Some people love the stress. They love that like their
boss
staring over their shoulders.
If that,
and like,
yes.
Get this done.
Yeah.
In that case, don't test your backups.
Not only do you need to test your backups, but you need to time them. You need to know exactly how long it's going to take you to recover a 4 terabyte database. Right?
Okay, I'm going to play.
You need to monitor your backup logs, right? You need to make sure that they're actually completing successfully.
So I have to be Captain Obvious here. For the people watching, this question did not come in, but I'm going to ask it on their behalf. How in the heck do you test a multi-terabyte backup on a regular basis?
Well, if you don't, you will be.
But I mean, like it's so large. Like, how do you test it?
It's very large, but you know what? If you have a very large production environment, you should at least temporarily spin up a very large staging environment occasionally to test your backups. It should be a part of at least a monthly process, right? And I think that most companies don't do that, but that's one of the things, right? Yeah.
I can feel it. I can relate it. That like if you have like multi-terabyte database, it could be painful to test it. But believe me, it's gonna be more painful if you lost your production data and lost.
It's gonna be more painful, and it's gonna be very expensive to your business, right? So compare the cost of temporarily spinning up, especially in today's times of cloud, temporarily spin up the resources required to recover and test recovery of this database, as opposed to don't do that, and then something happens and you are down for 4, 6, 8, 10, 24, however many hours, right? Yeah.
So what if, like, though, so a lot of the automation and things that are out there are designed to do backups for you or keep your data up, or, now we've got, databases as a service. Some people running on Atlas, other places. Do you still have to worry about your backups then? Do you still have to test them?
So most of the time you will test those when you spin up a development or a QA environment, right? Because you will want to be utilizing real data, or at least a subset of real data for that. So yes, you should still test them, because even if you do a total file system copy, right? If you do a physical file system copy, and that gets you to a particular point in time, but if you want to get past that point in time, then you will still need to do applying of the op logs like Andrew was talking about earlier, right? So you should still be doing it, right?
So Andrew, you need to leave in a couple of minutes, so I want to be mindful of this.
Right.
Maybe give us a few final thoughts before you log off the stream here. From a backup perspective, any tips, tricks that you want to convey to those who are watching?
Yeah, like
around PBM, right?
So. Anyway, if somebody gonna take like one scene from this, I would like that be the thing that just like check your backups and test your backups, and again, you can start not at least it's much better just to check what happened to your backup. Let's say because again in PBM we put a lot of effort. We are not guarantee for 100% that all your backups are gonna be fine and we finish all your backups and no errors gonna happen, because you never know. But we put a lot of effort to this feedback and to be sure that if something spoils the integrity of the backup, if something went wrong, so we would notify user that the user gonna see that this backup failed, and they shouldn't rely on this backup anymore. So let's say let's just start from checking the logs and checking the data of backups and be sure that it's everything all right. But of course, I strongly encourage everybody to test backup and to put some effort to this. So yeah,
and so as much as it's hard, as much as it's hard for developers sometimes to think about the backups, about the infrastructure, they want to write code, it will really help them out if they do check those things out occasionally.
Yes, and you can think of this from another perspective. Okay, you can maybe write some code for automatization of this testing process.
Yeah.
So yeah, win-win.
Yeah. Yeah, and PBM, Percona backup for MongoDB allows for the point in time recovery, right? You set up and you do point in time PBM backup triggers, then it starts capturing the change log, the equivalent of the op log, right? So that you can apply the changes for both the replica sets and also for the sharded clusters, right? So it's similar to the redo logs, and that it does the incremental backups as you're going along. So you always want to take your larger backups and then your incremental backups so that you can get to where you want to be faster, right? So Andrew, can you tell us a little bit more about specifically, how PBM does those type of things, right? Because you're the one that codes a large majority of the features. that we have.
I'll try, but I'm probably gonna drop off in
Yeah,
4 minutes.
Andrew has a personal obligation, so he needs to bail on us, which is cool because we can come back and we can do a bit more deep dive.
Yeah, maybe we can make this another iteration of this meetup and to talk, or maybe I can come to your podcast, Matt, and to talk about this.
That I love to
we can
talk
arrange.
to people.
Yeah,
I'm a talker.
Yes, and I love to talk about this like guts of system of PBM particularly, and to dive deep to some
Okay, Andrew,
juicy technical stuff. But
we'll
again, last closing words from me for just try PBM. Just drop us some feedback if you're gonna find some bug or some issues. We would love to hear from you and to deal with it. So yeah, just try it out.
All right. Thank you, Andrew. And we appreciate you swinging by here, chatting with us. We'll have you on another episode of either the podcast or the live stream here. And we'll get a little bit more deeper into the weeds.
Sure. It was pleasure. Pleasure to
Thank you.
to
Thank you, Andrew.
Yeah.
All right.
Thanks for having me. Bye.
And then there were two, Kim. Then there were two.
And then there were two, right? So then the other thing is, again, the best practices type of things, right? Take your backups, test your backups, do the incremental backups, test them, make sure they're doing everything you need to do. And make sure you have your settings correctly. But just all those things are the important things. The other thing too that PBM does, it does allow you to back up to S3 and S3 compatible storage places, right? So you don't have to do it all on-prem or local, whatever. And that's what I was talking about a little bit before. You can spin up the resources temporarily to test the backups and then get rid of them. So,
and to do these level of backups with Mongo without PBM, and the reason we built PBM was you had to pay Mongo for Ops Manager and the enterprise thing. So that's why we took functionality that we felt should be in the open source space and added it to PM or PBM.
Yeah, and that's what we kind of do in general. We take the community version of Mongo and we try to add features that are enterprise level in our own ways, right? So
Okay.
Yeah, great. And so that's the and the backup snapshots, just the different things. Again, the sheer size of the backup sets and the data sets these days. It's super important to plan for these things ahead of time and to think about these things. So.
And I mean, let me throw out to the developers out there. So my big thing the past few months and going into next year is about how much database design impacts the long-term scalability of systems. And as we talk about some of these large backups and these large scale systems, one of the biggest issues that I continually see, and this is not backup related specifically, but is a lot of testing that occurs ends up testing at a micro chasm of what is actually the production size. And, people go through, they build new features out and they build it on a 20 gig data set. And then when they get up to a multi-terabyte data set, they don't know why it doesn't work the same way.
Yeah.
And that's something that I think, my PSA, looking in the camera, everyone, is everyone, realize that, as the workload changes, as the data size changes, things will change in how the database, whether you're running Mongo, Postgres, MySQL, Oracle, SQL Server, at scale, different decisions are made internally by the database, by the optimizers, and you can have something that works today that tomorrow is completely broken.
Yeah, and Matt, a big point of what you just said, we've been talking about data sizes. We've been talking about these big data sizes, but we also have to think about the number of write operations, the number of read operations, the number of ops that are hitting the database, the ops that are hitting the disk, the network impact, right? Because taking these backups of these large sets will also impact writes and network operations. and also impact cost, right?
Yeah.
Because you're sending network traffic outside of your containers or your zones or your regions, et cetera, then that's network costs in most of the large cloud providers, right?
Yeah.
So all of those things come into play.
Yeah. Yep. Absolutely.
Yeah.
So I'm looking. We don't have any questions, but we did have quite a few people who just made some comments here and there, and we appreciate you hanging out with us today. Kim, is there anything else you'd like to cover? We've got about a few more minutes if we wanted to cover a few extra things, or we can end if nobody has any other questions.
Well, I mean, we've talked a little bit about scaling. I mean, scaling is always important. These are always the things that you're taking into consideration, whether you're talking about backups or not. And the idea, developer audience, schema lists, but you still need to think about your database design. Right? It's not schemaless, because if you go into that, even with 5.0, once it's actually stable and running correctly, and you can change your shard key on the fly, the thing you have to think about is when you're changing that shard key, you're going to be doing more write activities. So that's also going to be a performance impacting activity.
Right.
So you always have to think about where you're going to do your backups. If you want to, if you're large enough, if you want to do a secondary, but also just whatever other changes you want to do, right? So,
yeah, absolutely. I mean, that's a key thing, right?
Yeah.
Performance changes or changes to things can be changes for the better or for the worse.
Right.
And a lot of times performance issues and scalability issues in any application are whack-a-mole, right? So this is not database specific.
Right.
I have seen numerous cases where you have an application and you have a bottleneck that is, choking, some sort of, throughput to the system, some sort of like, the number of, threads going on, and you open that up and you go from like, great, we were bottlenecked and we only were able to do 10 things at a time. Now we can do 30. And now you've just made the system way worse.
Right.
Because all of a sudden 30 things happen.
Right.
Yeah.
And changes in the engine behaviors of the databases, whether it's Mongo or another one, but changes in Mongo specifically, chunk management, chunk movements, jumbo chunks, where the jumbo chunks are identified. That was a big change that happened in a 4 version, is where they moved it from the Mongo S to the MongoD, and all of a sudden the MongoD actually knows what size it is, the primary of the MongoD. Hey, this is a jumbo chunk. We need to split this. And so you're getting more splits, you're getting more migrations. There's more writes, more impact to the database, but less jumbo checks, better chunks, better balance across the way. So you always have to think about the things that are the improvements and how your application specifically behaves and how you think that those changes will impact you before you even consider, hey, should I upgrade or not? Don't always go for the latest, greatest, fanciest thing. Think about your application, how it works, and how your customers and your users use it, right?
Right. Yep.
Yeah.
Always good advice. Well, Kim, thanks for swinging by and stopping by the meetup. We appreciate all of those who are watching either live or offline. The recorded version of this. If you have future topics you would like us to cover, if you'd like to be a talker, a speaker on this, just come on and chat with us about something you're passionate about. We do these every week. We've got a MySQL one the first of the month, or the first week of the month, then a Postgres one the second week, then Mongo the third week. Then we talk about PMM and observability in the database space the fourth week. So next week we're going to be having this same time, same day. It's going to be on observability and monitoring. So if you're interested in those topics, feel free to swing by. We're going to be talking about, some things in Grafana, some other things. But please do come out. And don't forget to check out my podcast, The Hoss Talks Foss. Always love to talk to people there as well. So if you're interested in that, I would encourage you there. But thank you, everyone, for stopping by. We appreciate you hanging out with us for about an hour, and we'll see you next time.
All right, great. Thanks, Matt. Thanks, everybody. All right.